Hello everybody and welcome to Slooh. Thank you very much everybody for being so patient and a bit of humour over there in the discussion boards about us starting late. I think it was Daryl saying he's run out of popcorn. But anyway, listen, we are here and we are still going to be able to bring you something, but the gremlins hit, the YouTube gremlins hit, I'm afraid. But here we are, we're on air. Well, I'm on air and we've got a special guest coming up. I just need to check to make sure that this is getting through to the Slooh situation room, and it is. So anyway, what are we going to do today? Well, we unfortunately can't bring you, because of the YouTube gremlins, 360-degree video, but we are still going to be showing you around the observatory. And in fact, this thing right next to me here is the Canary 1.5-meter telescope. Now we're going to show you all sorts of stuff today. If you want to see anything in particular, then post a message in the main thread in discussion boards about the tour and stuff like that. Cameron's already asked for a few things. And the first thing that Cameron has asked for, excuse me, I'm shivering, and excuse us if we're going to sniffle. And don't forget, the us I'm going to introduce in about 2 minutes' time. But one of the things that Cameron asked is, could you see the domes open? Well, yes, you can. So here we go. So I'm going to not actually be doing this. I'm going to be doing this in the same way, controlling all of the domes in exactly the same way as they're operated at night. So this is all through the Slooh servers and stuff like that. So do hold on 1 second. And as I say, while I'm doing this, thank you so much for being so patient. It worked brilliantly last night, but we will have, what we have got is 360-degree video that you will, excuse me, be able to watch. Unfortunately, not live during the show, but you're still going to be able to take this virtual tour, which also means you're going to be able to take a virtual tour. We've already worked it all out. My guest today, my helper, our new operations manager, who I'm going to introduce very shortly, he apparently has volunteered. Sorry, let's repeat that. He has been volunteered to sit on the bonnet of our hire car with a selfie stick, with the 360-degree video camera on the top of it. And we're going to take you on a virtual tour of the entire observatory. And by doing it in that way, you're going to be able to see it in full 4K definition. So unfortunately, it can't be live, but I'll tell you, it's going to be worth it because it's so cool. We were so disappointed that this didn't work out. But anyway, come on, let's open the dome. So I'm in Dome 1. So this is what happens every night. So I'm just going to actually set one little thing so it doesn't close on us, because we've got some clouds here, which you may see in a minute. So here we go. Here goes the dome. And let there be light. And there was light. And it is really cool the way these domes open. So and hold on 1 second. I'm just being called from someone else because there might be a problem. Hold on 1 second. Right, sorry about that. As you saw, the dome is now open, but I think without further ado, it is about time that you saw another dome open. So I'm in Dome 1. We are going to now open that dome over there. So do excuse us, we're trailing cables everywhere and sniffing and doing all sorts of other things. So we are now going to see Dome 2 open and our special guest in there. So hold on 1 second. Oh, no, I did the wrong dome. I did the wrong dome. Cox did the wrong dome. You can't get the staff. Well, you can. We've got him here. Right, let's open that dome over there. Oh, do excuse me, sniffing. Whoa. So there goes Dome 3 over there. And inside, there is our new member of staff for Slooh's 2019 expansion. That is Andrew Dumbleton, our new operations manager, who's been with me since last Saturday. Now, Andrew, I said I was going to open the dome so that you could actually get out of it, but if I promise not to show you on camera, will you be able to climb out the top, or shall I close that shutter? Right, we're now going to show you how the domes close. So Andrew, stand clear. And then Andrew's going to join me over here and we can have a good natter about what we're up to here. So we've just had a message actually from Slooh HQ, George Moser over there. He's saying, forget the government shutdown and winter storm, GIA. The real crisis is the technical difficulties we're facing right now. George, we are, just tell me in that little chat to make sure that we are actually okay at the moment. And we're going to be welcoming Andrew Dumbleton into them. Andrew, can you reach around and press the button if you poke your head through there? I won't show you again. And you can just open up that. Can you reach in there? So that's it. Andrew is actually just opening the shutter a little. Right, so Andrew can now come in to Dome 2. So there we go. It's a little like being in a submarine, you know. But George, let me know in chat. Make sure that we are actually on live. So anyway, Andrew, welcome to Slooh. How are you? And
welcome, community.
Yeah. So they're all very patient out there. Apparently, Darryl has got his second lot of popcorn on the go because we were a little bit delayed. But anyway, first of all, Andrew, big welcome to Slooh. You've been a Slooh member since when?
2004, so just after we went general availability, I think.
Okay, so a real old hand. And you've now joined us full-time as operations manager. You know what some of that stuff entails, but this trip was your first day, wasn't it? When we arrived here, your first day at Slooh. First of all, tell some of the members out there, I better actually get you on screen. Tell some of the members out there, what was it like? What was your first impression when we actually arrived at the observatory?
Well, of course, we arrived in dark, following a tortuous routing around several fiestas.
Oh yes, that's right. We had the fiestas. So normally, I was telling Andrew, it's an absolute doddle to drive up to the observatory. But our normal route 1 that I took, I said, this is the quickest. It's always easy. We hit a roadblock, and it was fiesta weekend.
Yes.
So we took the alternate route, and what happened then?
We hit some fiestas.
Another fiesta. So yeah, in the end, we came for a rather circuitous route, and the fiestas are probably long since closed since then. But so we arrived in the dark. I mean, was it possible to have any impression of the place at that time?
I mean, it was good to sort of drive with the headlights on up to the domes, because one of the first big impressions is how big the domes are.
Yeah.
We don't often see the size of scale because we don't often see you working in the domes unless it's a maintenance visit.
Yeah.
So actually being here and standing in the domes, it's just enormous.
I mean, you could fit 2 cars in here comfortably side by side.
Yeah.
Well, put it this way, 2 UK cars maybe, but, you know.
Yes, fantastic. Now, I can't remember because we were so tired that night whether we actually looked up or whether it was cloudy. But certainly since then, another big thing is the skies here. They're just fantastic.
Right.
And I remember us standing out the dome after a maintenance ops visit. We were just standing there looking at the sky, and it was just almost 3-dimensional. It was absolutely fantastic.
It was, and you know, it's very difficult to convey that to anybody. You know, I find, and it's just you look up and it's inky black, and it takes on this 3-dimensional depth, and then you know you start to lose the constellations. I do, because there are so many stars visible that the constellations that you know the only stars that we normally see, certainly from the UK, kind of disappear in this melee of other stars.
And for pointing the telescopes or seeing something, we often have to rely on the sky. We don't recognise it ourselves, apart from just cardinal directions. And that's the other thing, not just night. The daytime views up here as well, although nothing to do with the job, are just fantastic.
Well, let's share that with people. So we'll open up this dome again. In fact, let me just. Do excuse us, folks. we're juggling at the moment.
Yeah, this is another aspect of the job, the remote ops. The remote ops and learning all of the control systems
Exactly.
is another exciting.
So I mean, this is fairly new to you. So give us a bit of a tour. So we can see over there, right on the horizon, there's a building, a kind of orange building. You know, what's that over there, Andrew? Explain to the viewers what we've got.
Well, that's the residence where astronomers and engineers and control room staff will live while they're on site. Obviously has rooms to sleep, has day and night rooms. So we're in, I think, a day
sleeping rooms.
So we have to be quite quiet when we're going into that half of the building, because there could be astronomers sleeping as we're sort of going in and out. Has a canteen, of course, so we're kept fed. Yeah, it's a wonderful reception.
So tell everybody out there who hasn't been to the residence then, because I think over the 14 years I've been coming here, I think a lot of people think it's like a luxury hotel. I mean, is that what you would describe it as or not?
Not at all. I mean, I've been to some of the BAA Winchester weekends. So the closest I would put it is those sort of university dormitories. So they're quite clean, quite functional. They're not sort of 3-star hotel level, but they've got everything you need.
Clean and comfortable.
Yeah,
I think.
Showers and a bed, which is a
comfortable.
normal thing when you've had a night at the observatory and you're tired and you just want to get in and crash.
But you were quite surprised, weren't you, when I showed you something that I had in my bag that I leave here, and it had to do with the shower. You did think I was a little bit mad there,
I mean,
you?
some of the things you warned me about to bring, like work trousers, you know, but to find you had a shower head in your standard kit was quite amusing. And also scary. So immediately I went off to try the shower. And luckily my shower head is perfect.
They did do a minor refurb on the rooms last year, but up until then, the shower heads kind of came out a drop at a time. So I decided then to leave my own good quality shower head here. So anyway, enough about the resident. And well, how about the food? I mean, the food, to me, I still can't get to grips with whether or not the chefs are good here, but stuff tastes different up here. And I think it's to do with the altitude. I mean, we're up at 8,000 feet here. You and I, we're not that unfit, but, we walk 100 yards or up a slope and you're out of breath at the end of it.
Yeah, certainly the first 3 days, I had to be very careful how much exertion I put into things. So, especially climbing in and out of these small ISS-shaped holes. Yeah. So it's like being on the space station.
Yeah,
sort of floating through small openings to get from one place to another. And just going from one dome to another 2 or 3 times and you would be out of breath. The other thing is, of course, water. So important to have some water up here with us. And sometimes, like today, it's a bit cold. So it is the padded clothing.
It is getting, I would say, very chilly right now. You have yet to benefit, actually, or experience the benefit of being up here. So when you are up here, you do get out of breath. And, you can get quite tired. Just a normal working day up here can make you absolutely exhausted. But while we're up here, for this week or 10 days, our bodies are reacting to that and they're generating loads more hemoglobin. So when we go back down to sea level, our bodies are taking on loads of oxygen and actually you feel quite good. You'll feel quite good for a couple of days and then probably crash.
I'm interested to see the effects of that, whether it makes me just talk more or sleep more or just can't stay still.
Now, I explained it at the beginning that we can't do the 360, but we're going to be doing these 360 videos. I was right, wasn't I? You did volunteer to sit on the car bonnet with the 360 video camera.
As long as it wasn't midday,
and you checked your... Well, I asked you last night, actually, have you got travel insurance? And you said, yes, but it doesn't cover stupidity, or it doesn't cover stupid. So anyway, that's kind of... We're going to show people, I think, a little bit more of the surround and the telescope as well, that we're standing right next to here. Look at this beast. This is the half-meter telescope. But, Andrew, maybe tell people why we're here, what we're doing. I mean, this isn't just a training exercise for you. So what kind of work have we already been doing up here?
Well, we've already been doing the maintenance on Canary 3 and Canary 4. Canary 3 was out of commission, of course, because of the focuser issue. But whilst we're here, we're also sort of cleaning the optics and doing any collimation exercises, any pointing exercises. Canary 4, unknown to me before we came, we actually did an optical telescope assembly, so just the tube part. We did a swap on that to an Edge HD. But of course, the maintenance of that meant that we also had an exercise to renew the pointing model on that and also collimate that.
Yeah. So it's been a pretty intense. I mean, it's intense for me coming up here, and I've been coming up here for 14 years. But this is a lot of. I mean, you're a very capable chap, but this is a lot of new information to learn, and there are ways of working up here that are different to your own backyard.
It's the information systems that you use, where you can work both locally and remote, but you can also screw that up if you don't do it in the right sequence. There's the equipment itself. I mean, this beast is just nothing that I would touch in my backyard. I would normally be used to attaching cameras that have a 1.25 diameter dimension. I mean, these are just 2 or 3 inches or 4 inches.
Well, exactly. I mean, it's really difficult. This is the focuser on the half-meter telescope. And you look at something like that, and viewers at the moment getting a great view of it, but it's very difficult to tell the scale until I start putting my hand in here. And you can see that the focuser diameter is actually larger than most amateur astronomers' telescopes, let alone this beast and this great big rectangular black thing at the back is the filter wheel that contains 2 carousels in there, and then on the back of that we've got the ultra cool CCD camera as well. So what work have we got still to go then, Andrew? What do we got?
It's mostly in Dome 1 and Dome 2. So you've been busy cleaning the optics and wiping it clean, which is why it looks nice and shiny. I mean, actually, Paul's talked about the amount of dust that accumulates up here. I wasn't actually surprised when I came. The dust was there, but it was quite thin. So I think the Kalima has probably been kind to us, particularly as the visit hasn't been since 2017. But I think once, of course, we've touched these telescopes, there are calibrations to do, some of which we can do remote.
Yep.
So you've taken me through those systems and the daily ops. And of course, because we are somewhat wind affected, particularly in Dome 1, we're looking to do something with the shutters to provide some additional protection.
Yeah, so somebody, in fact, I think, let's have a look in the discussion boards. Somebody was saying there, if we can, increase even by a couple of miles per hour the wind limit in here in Canary 1, but if we can try and show some kind of perspective. In fact, if you take the camera there, Andrew, try and take it as far back there. Mind you, running out. No, pointing back here, because what I wanted to show people is just how far above the dome wall this camera actually points. So I put a little bit more leeway in there. Come a little bit closer, just in case we pull that out. But maybe can we see the end of the telescope tube? So that's up. I'll stand up. Try and stand up here as well to give you some kind of perspective. But I'm not sure if you can see You can see the dome wall there as well. So you can see that the Canary 1 telescope is so large that it extends quite a way above the dome. But what you can see there at the back as well is the north shutter. We do keep it quite high already. But Andrew and I have been discussing this, and we actually did a member poll, didn't we, last year in 2018, to say, okay, well, what would members like up here? Would you prefer more operational nights in Canary 1 at the cost of maybe lost horizon, so maybe we can't point the telescope so low, or do we keep it as is and have a low horizon but lose some nights because of wind? And almost overwhelmingly, and I think our discussions since as well, are saying this is Slooh's flagship telescope. We really should be making the most of it. And if that means raising the horizon limits a little bit, then so be it. We've got other telescopes that can still get down quite low. We will still, with Canary 1, the half-meter telescope, because of the way the domes work, we'll show you this actually on the camera by operating the dome. And we'll be showing you actually the telescope moving live as well, so that will make more sense about this meridian thing which Cameron was asking about. But we'll show you that actually the eastern horizon will still be quite good because of the way the shutters operate. So Andrew, I mean, the other stuff that you've been doing here is the long promised seeing monitor. You've been working on that today. So tell people what that is and what information that's going to give them.
Okay, so that's a small box which has a camera in it with a sort of lens that you might expect on a DSLR. And it provides a small field of view which is meant to be directed at Polaris. And what it does is it takes up to 9 images of Polaris, and it basically detects how much it's shaking, how much it's scintillating, and will graph that so it can give an impression compared with other nights and other snapshots that same night of the seeing. So that's its basic function.
And the seeing is basically the stability of the atmosphere.
Yes, so we've looked out across the cities that we can just see, well, not cities but local villages, and we can see the lights twinkling, and of course the lower stars we can see twinkling, and that's a visual impact of seeing or bad seeing. I mean, it's never, I guess, totally bad here, or it can be worse, but when I was looking up, in fact, I could only detect the twinkling up to a certain level, and then higher above, it just got less and less. So it is pretty good here, but it's good to have a monitor just to sort of get some metrics on that.
I'll just turn down volume up a little bit, just in case anybody's having trouble hearing. But ratchet your volume up because we're sharing a single microphone because we weren't not quite as set up as we had intended. So anyway, so seeing monitor is going to be great because that means that members will be able to see the conditions, a measured condition of those seeing conditions, the stability of the atmosphere when their missions are running. And that's going to be actually part of the new website, part of this extra telemetry that we're going to be providing members. But for the moment, let's, Cameron, we're going to hop over to the discussion boards to see if there are any questions there. But just before we do that, Cameron was asking, maybe actually Andrew, if you could come around this side, maybe. And this is the other thing that Andrew is having to get used to as well as anybody else who comes to the observatory for the first time. These are very much robotic observatories. They are not designed to have people inside them, let alone two big blokes like us inside it. But Andrew, if you can point it over to the other dome, because we'll show people what they can see. Yeah, that's good. So that is Dome 2 over there. You can see there's a little white post on the left-hand side. That is the all-sky camera, and that's kind of tipped towards the domes. You can see it's not level, and you can see that from the view at night. And the reason why it's tipped like that is, you may notice, we can just see the tops of the domes when the domes are closed. So that's our way in the morning of checking to make sure that, yes, the domes are closed. And it also shows us when we get icing here. And when we do get icing on the domes, that can be about 1 inch thick. But inside that dome, we can see 2 telescopes. So we can see the large black tube there. That is the Canary 2 wide field telescope. So it's similar to the half meter. It's the same type of telescope. In fact, it's just slightly smaller. It's got a 17-inch primary mirror. But you can also see, hopefully you can pick out on the top of that, you can see there's another kind of more traditional telescope. And that is our little, that's the Canary 2 ultra wide field telescope, which is piggybacked on the back of the big telescope. And then just to the right there, you can see the weather station. If Andrew tilts up, you can see that we've got some cameras here actually from the EAC, the Institute of Astrophysics of the Canary Islands. And that's in that kind of little tube thing. And we're hoping to get a feed from that. And what they've done is they've actually lined that up with our lightning rod, which was already a little bit of a blockage. So sometimes you'll see if you're pointing in that area of the sky we see it quite a lot actually on Pinwheel Galaxy missions. You'll see a kind of large shading going through the ultra-wide field. You can see it on the ultra-wide field better. And that is because the telescope is pointing right at the lightning rod. And then just over there on the right-hand side, you can see a kind of tall tower. We pointed this out to you the other day, but it's really spectacular today because it's in the bright sunshine, and that's one of the large solar telescopes here. But let's take a look at how these domes operate, because we'll close up Dome 2. So let me just go over to our admin page, and don't forget, if you've got any questions for me or Andrew, ask Andrew what he's making a Slooh or working here or whatever else you want to ask, and do that over in the discussion board. So have a look at how these domes close. One side's going to go first and then the other side. So here we go. The noise they make, you'll hear it when we operate the dome that we're standing in now, can be quite horrible. It sounds like 100 fingernails scraping down a black ball. You can just about see the other side closing shut. And there it is, all snug in its bug. So, Andrew, let's maybe go over the other side, and we'll show members again how, if you go over there and then maybe point over to Dome 3, and we'll see if we can see any of the equipment in there. Can you hold the camera? Make sure that you can see what we're looking at as well. We'll just open up Dome 3. Because Dome 3, Andrew, you've been working in there kind of quite a lot so far. It's a single dome, but we've got, 3 systems in there, haven't we?
Yes, I was surprised. I thought there were only 2, and there were 2 systems in Dome 2. But when I got on there, there's 3 fairly compact, close together systems, and the orchestration between them means there's sort of inches as they're passing each other, and the clearance is quite small.
I mean, when you say small, I was showing you the other night when we were working in there. I think so what we've got in there, if you can see this, folks, on the left-hand side, you can just see a white long tube. Now, that's the Canary 3 Deep Sky telescope, which has now been back in operation over the last couple of nights. We've still got a little bit of work to do on that to fully commission it. But then in the middle, the thing kind of sitting tallest there, that's the solar telescope. Now, all of that equipment, one of the jobs that we've got to do while we're here, all of the equipment in there needs to be recovered in all of that lovely gold foil that you saw before, because that dome has to be open, not as much as you can see it there, but it has to be open very slightly to just give the solar telescope, the Canary 5 solar telescope, a clear view of the sun. And then on the right, you can just see we're looking at the front of the telescope, which is the Canary 4 solar system telescope. Now, this gives us our smallest field of view of any of the Slooh telescopes. And Andrew and I are going to be working hard when we get back to the UK to really tune that telescope up. We've seen some good signs, haven't we, Andrew, so far, that we're maybe on the right track to improve that.
Yes. It's a bit of effect, I guess. It looks like trailing. We're not sure whether it's wind or trailing, but also I think on all of the telescopes we're going to be working remotely to try and get the best images, the best calibration out of them all.
Exactly, and I mean that's having you alongside me working in operations means that generally I think we're going to be able to keep on top of some of this work a lot better than we've ever had to do. But we are totally exposed there, so we'll just, while we're keeping an eye on that, we'll just close that up as well. We have got some very high winds today and forecast, but Andrew was saying there, that we'll be working remotely as well. And what we try and do, and this is one of the things I've been saying to Andrew, is what we try and do is we even when we're at the observatory, we try and operate most of the equipment robotically when we can. So the only time that we're in the domes, in other words, when we could be causing trouble, clunking into something or ripping out a cable accidentally, something like that, we spend as little time as possible in the domes. And really we're in here to perform maintenance work or to make manual adjustments. And Andrew, we were looking we were doing a lot of that the other night with both Canary 3 and Canary 4, because you were doing the collimation on Canary 3, and we're still going to have another go at that, aren't we? We think we can get that a lot better. And we've been monitoring the images over the last couple of nights when we've been running these tests. And Canary 4, actually, I think we certainly have reduced the trailing that we were seeing dramatically. We collimated it, I think, and collimation. Maybe tell the folks at home what collimation is.
Okay, so when we look at an out of focus star, we get these concentric rings, and the concentric rings, or well, they're supposed to be concentric, but often you can find after shipping a telescope or after some time, it's like a hole, like a polo mint, and the hole can be off to one side or the other side, and the screws usually on the front of a telescope or an SCT type telescope, and by altering those screws, there's normally 3 of them, you can bring that polo mint hole into the center so that it's all of the rings are totally circular and totally within one another, equidistant, and the illumination of those bands, those rings, is the same on all sides. Occasionally, of course, we have to fit a camera, like we do on the RASA, in front of the telescope, so we can get some unavoidable cable drop, which causes a line. But apart from that, once we've got that centered, gives us the sharpest view that we can possibly get.
And those shadows are actually being caused by the different optical elements. So most of our telescopes, certainly the reflecting telescopes, have 2 main optics. And in fact, we could probably take a look. Will you be able to reach that to see inside the half-meter telescope? We're just moving a whole stack of stuff, so hopefully we won't undo a cable or anything. Right, there you go. That's good, Andrew. So what we're doing now is we are peering inside the half-meter telescope. Andrew, just pop your hand in there in the field of view, just so that, so people can kind of see the scale of this, and we'll maybe move it around a bit, and you will be able to see this in some of the videos that we're going to release as well. So that's our primary optic. So that's the primary mirror, and that's right at the back of the telescope. But there's another mirror in here as well. Andrew, if you can go to the secondary mirror now. Now this is at the front of the telescope. So that's a great view, isn't it? So now that thing is something like 6 or 7 inches across. It's nearly, it's about 150 to 180 millimeters across. Most amateur astronomers don't have a telescope that big, let alone having a secondary mirror that big. So what's happening is, you can see the view there. The light is coming in where you see those veins, and it's those veins holding the secondary mirror that actually cause the spikes on bright stars and stuff like that we see. So that the light comes in, follow that with the camera, Andrew. So it comes in and then it goes into the telescope and onto the primary mirror, onto the big primary mirror at the back, the thing on the left. Then it goes back up to the secondary, Andrew. So it goes back up there, and then the secondary mirror is then focusing all of that light back down through that big tube that you saw, which is called the baffle tube, and that sends it down. In fact, Andrew, you can now come outside the telescope, so it's coming all the way back through the body of the telescope until it comes out the back. So here we've got, so the light is focused back in, but by the way, the Canary 2 and Canary 1 telescopes are called CDKs. They're called corrected Dal-Kirkham. So the corrected bit is there's inside here, inside the tube, there's a huge optical element, and that's the correcting optics that make what's called a flat field. So on a poor quality telescope, you'll see nice crisp stars right in the center of the image, but as you go out to the edges, they'll get elongated, they'll become out of focus, stuff like that. But an expensive telescope like this, and if you want one of these for Christmas, then you're going to have to be saving up your pocket money for quite some time. I mean, it's tens of thousands of dollars. But anyway, so the light's coming back here. This is just a tube. So all of this stuff back here is tube. So this bit here is the focuser. Now, these bits, you might say, well, what's the point of having all those bits on there? Well, you can see there's one large one and there's two small ones. Maybe come up a bit closer, Andrew, on this. So you can see there's a large bit here, and then a couple of smaller bits up here, down here. I'll put my finger down there. Now, those are spacers. So you think, okay, well, why do you want a spacer? Well, all telescopes are designed, their optical design is designed to create the perfect image at a fixed position at the back of the telescope. So Andrew, if you move that back and capture this stuff as well now. So on any given telescope, there's an optimum place to either put your eyepiece or in this case, your camera. So this big thing here, as we said right at the beginning, that's a filter wheel. So this contains two carousels. You can see in discussion boards, actually, we've got some live video of that working, which is always pretty cool to see. But then we've got the CCD camera at the back. So this is the thing that's cooled to minus 40 degrees C at night. But just inside here, just it's just back from the front of the case is the actual CCD chip itself. And all of these spacers are designed to locate that CCD at the perfect image plane, the perfect place for this particular telescope design, for that image to come together absolutely perfectly. Now, unfortunately, you couldn't see the fruits of my labor today because I've been cleaning the optics, which is a huge job on a half-meter telescope. But I did take a photo of it that we'll share in discussion boards a little bit later when I was a quarter of the way through. So that'll give you an idea of how much dust we've been putting up with over the last little while. Now, I think let's hop over to the discussion boards to see if you lot have got any other questions. I'll just check our Slooh Slack and everything looks to be running nicely. Thank you very much. So, folks, don't forget, if you want to ask any questions, then you can come over here. I just need to do a refresh on this in case anybody has asked any questions. Just checking the other domes to make sure those are closed and nice and safe. We will be showing you, by the way, Canary 1 before the top of the hour. We will be showing you the Canary 1 telescope slewing because there was a question there. But let's just hop down here. Do excuse us. As somebody said earlier, talk amongst yourselves. And you lot were so, thank you all so much for being so understanding earlier. You were talking amongst yourselves for an hour until we could get all of this. Oh, by the way, Dave Larkin, yes, you guessed right in discussion boards that it was a fellow Brit, and you'd obviously seen Andrew answering some members' questions over the last little while. But anyway, we're just hopping down here, seeing. Yeah, Tony says if only he was 50 years younger, he might have been tempted to apply for the job himself. So, right, Jay, like a rundown of what's happening with each scope, any mods, repairs, cleaning. Okay, so let's go through this one by one. Can you frame me a bit better on that, or you could leave it up there and join me over here, actually. Yeah, let's see if we can do that. Join me over here. I never think it's very nice for people just to see my ugly mug, especially when we've got somebody who's far more good looking. So let's take a run through then, Jay, all of the work that we're doing. So Canary 1, we've cleaned all of the optics. We are tonight going to be, we've got high winds tonight, so in fact it would be too windy for Canary 1 to operate anyway, but it's going to give us a superb opportunity to run some tests on raising the shutters. So one of us is going to be raising the shutter with our head above it to kind of anecdotally feel what the wind speed is like. And we're going to be taking a bunch of long exposure images, just like normal ops do. And we're going to be seeing how much shelter we can give it, how high these shutters need to be to give it an extra element of protection. We've cleaned all of the optics. We'll be doing a full calibration. We'll be making a new calibration library for this telescope, so taking new flats as well. We will be cleaning the filters. It's all pretty clean at the moment, but we will be cleaning that. This one the camera has one fan that's not operating, so we'll send another one of those over to get that installed. That is about it. I haven't forgotten anything in Canary 1, have I? Okay, so Canary 2, what have we done in there? Well, we've had the major clean in there yesterday. We've had a lot of IT work to do in there as well. That's taken up quite a few days of my time in there. But basically, it's going to be the same kind of work as Canary 1. So we're also going to be doing a new pointing run, actually, in Canary 2, because the pointing has gone a little bit off over the last couple of weeks. And we'll also be aligning the ultra-wide field, Canary 2 ultra-wide field, better with the main telescope there. So that's it in Canary 2, isn't it? And then Canary 3, I'll kind of look over where it is. So Canary 3, we have, well, you tell everybody because you've been doing that work. What have we been doing on Canary 3 and what's left?
Well, like I said before, we've cleaned the optics on Canary 3. We hope fixed the focuser.
Well, we tightened up. We had to remove the optics, which is actually, not a great job to do, and it's not something that you do, quickly or take that decision to do quickly, because the secondary mirror was actually rotating and was loose, wasn't it?
That's right. We were turning the camera or trying to remove a ring which holds the camera on, and we could see the secondary optics inside were sort of rotating.
Yeah.
And that was sort of bound a bit more than we would like.
So we've still got the collimation to finish off on that. We've still got some focus calibration as well to do on it. We are also going to be creating a new calibration library for that, because we were doing some testing last night. And for some reason, the camera earlier on or later in 2018 was not reaching a very good cooling temperature, but we've tested it last night and it is reaching a good cooling temperature. So new calibration library for that. That will decrease the amount of noise in that hugely. So we'll get that done. We've also got, we will be doing when we're back in the UK, doing a lot of work on the processing, recipes, presets for that as well. So then we got Canary, we fixed focuser on that, of course. Canary 4, as you say, we switched the telescope tube over. So we've now got the Edge HD 1400 on it. We appear to have greatly resolved the tracking issue on that, but with the reservation that it was last night was only our second night of testing. So, we're still, with so much wind out, the jury's still out on that one, isn't it?
Yeah. In fact, on Canary 3 and Canary 4, we're going to do some testing on the necessity of the dew shield.
Yes.
To see whether on Canary 4 the dew shield is affecting its tracking during sort of higher winds. For Canary 3, we're looking at some flaring around the really bright stars, so it doesn't affect the normal missions without bright stars in, but we have noticed some flaring. We'd like to understand that.
Yeah, so we're still not at the bottom of that one. Canary 5, we are going to be starting our work tomorrow on Canary 5, the solar telescope, and that includes, we've already cleaned that one, but we're going to experiment with a couple of different types of camera as well. But we're also going to be installing the Canary 6 solar telescope, which will be on the same mount. Now, that's not going to come into production straight away, but we're doing the installation now, and we're hoping that, depending on what features are visible, we'll be able to, in the short term, use either, but we won't be able to use both at the same time for another couple of months yet, because we need some coding to be able to do all of that. So we've got the seeing monitor as well that you're installing. We've been fixing or trying to get to the bottom of an issue with the weather station as well, which when it gets above 25 miles an hour wind, it suddenly starts reporting 80 or 90 miles an hour, which I know we've got a few screenshots of that in discussions. But let's have another look through because Cameron's got a whole stack of stuff in here. So the dome's opening. So Cameron has said he'd like to see, he's got a big list actually. Number 1, dome's opening. Well, hopefully you've seen that. Canary 1 slewing, we will show you that in a second. The equipment set up on Canary 1, filter wheel, focuser, camera. So hopefully we've already shown you that. The shadow of Pico Deltadi stretching out over the ocean as the sun sets, and the sun setting over the Atlantic on the opposite horizon. Now, you've seen that a couple of nights now. What did you make of that? Because it's my favorite time of night here.
Yeah, it's just beautiful. It's almost undescribable, and just having the cloud layer below you, almost as if you could walk off the ridge of the mountain and start walking on top of the clouds. It's just magical.
But it's not just the Pico del Teide shadow, but I pointed out to you, I think, the first evening after we'd finished our day work, because at the moment we're kind of not doing day or night shifts. We're doing kind of 3/4 of each, I think you'd describe it, wouldn't you? But there are these other kind of strange lighting effects that we were seeing, weren't we, on the first night?
Yeah, I mean, I suppose I'd describe them a bit like we see at home, sort of crepuscular rays, but they were sort of obviously different to that. But it's definitely light and dark borders. Some of the optical effects I can't really explain, but they're just beautiful.
They are. There's peculiar things that seem to be coming up when we're used to seeing them, those shadows kind of going down and stuff like that.
You saw a flash, I think.
Oh, yeah, we've I must show it actually in discussions. Take a look, members, take a look at Pico del Teide Cam when the sun is setting, because there's one little bit of the edge of the caldera, of the volcanic kind of basin, that is just catching the last glimpse of sunlight. And we caught it the first night, wasn't it? Mm-hmm. I kind of thrust my laptop in front of you and say, look at that. And it was this brilliant orange red, and this just against the blackness. It was a lovely, lovely sight. So Cameron is also asking, I'd like to hear about the telescopes and their history, especially why you chose each of them and what you hope members would experience by using them. I think that's beyond the scope of the next 15 minutes, but that's certainly something that we can look at covering in practical astronomy, actually. Any upgrades or new equipment installations and how you hope they're going to improve the Slooh experience? Well, we've got loads of that. You need to watch our lunar eclipse broadcast on the night of the 20th of January. And we're going to be telling you lots more about that and all of the new equipment that's already been ordered, which will be installed in existing and possibly other observatories. So that's that one. Challenges. So Cameron's saying the challenges Slooh faces keeping equipment operational in such harsh and isolated environment. Well, Andrew, you've never been up here before. I often try and convey how amazing it is that this equipment can operate a single night robotically without any manned operation. I mean, the telescope that we're standing in front of now, the half-meter telescope, hasn't had to have any manual intervention by anybody, including the staff here at the EAC, for over 2 years now.
That's right. I mean, part of it is because when you do visit, I've noticed Paul is very particular about what he does and how he sets things up, how he cable ties things. Everything is so carefully done and carefully balanced, I think. So when we see this thing slewing, all of the equipment we've shown you, if we took that imaging train off, it's really heavy. The telescope and the mirrors are really, really heavy. And the mount is really, really heavy. And yet when you touch it, when it's in balance mode, it's just so light.
Yeah.
I just can't believe it. It just floats.
I mean, it's important to think about, we're at this professional high altitude site. And some of the professional telescopes here, and even cameras and all the rest of the equipment, they've been designed specifically. They've taken maybe 5 to 10 years of development, by which time they're out of date. We're using off-the-shelf, albeit incredibly expensive, high-end off-the-shelf equipment. And I've always said that the way we use that is in a way that most amateur astronomers probably couldn't use it in their own backyard. You know, you've run your own equipment in your own backyard, 100 yards outside the back door. And it's very rare that amateurs do that without having to just got to pop out to the observatory to do something, you know, and we just can't have that here. But anyway, we're running out of time. So calibration, we're going to be doing that during the week there, Cameron. So we will share more of that information. Now that there's more than one of us in Slooh Ops, you'll see a lot more of Andrew in the discussion boards answering some of this stuff. And in fact, creating new calibration libraries and new flat fields and stuff like that is something I'm going to be taking Andrew through over the next couple of nights, in fact. So just popping through, because we'll finish off with moving. We've got 10 minutes. We'll finish off by showing you Canary 1 slewing. We'll go to Stephen. Hi, Stephen. Thank you very much. he said, I've never been able to grasp exactly why an object can't be imaged when it's transiting the meridian, or in other words, when it's due south and highest in the sky. I guess it has something to do with the mechanics of the mount. Well, we'll show you that as well. So we'll do all of that. Carol's got a weird question. Carol, that's unlike you. This because the coastal village where my astronomy habits were molded was gutted by fire. Yes, oh no. After fighting the fire since New Year's Eve, when someone set, by the way, Carol is down in South Africa, when someone set off a flare, the change in wind direction and fierce wind caused flare-ups, 31 hours burned down, houses burned down, and 28 badly damaged. Oh no, that must be heartbreaking for somewhere that has that kind of special meaning to you. But so I noticed, Carol has noticed vegetation around T5 in the previous live cast. Is the location where the telescopes are situated prone to wildfires? Do you have plans in place? There are plans here, and in fact, when you drive up here, there are several special fire stations here, specifically because this is a national park. This is a Spanish national park, and it's massive. It's basically the entire top of the mountain. Now, have a look in discussions. If it's not there, I'll point it out. I'll dig it out for you, Carol. I've got a time lapse from the all-sky camera from a few years ago when the skies were red and the fires reached the edge of the caldera. Now, the vegetation when we're up at this altitude, we're right at the top, so there are no trees here. It doesn't really, it's not very combustible, this stuff. And in fact, although in the webcam views, even that you're seeing now, it looks highly vegetated. When you actually see it from above, Andrew, it's actually mainly rock, isn't it?
Yes, yeah. I mean, it's a bit of dry scrub, I guess you'd call it.
Yeah.
Vegetation, but it's mostly lava rock.
Yeah. So anyway, that one's there, Carol, but I'll share that video later. What else we got? We've got Daryl. Hi, Paul and Carol. On the same theme as Carol's vegetation question. When in the Canaries in December? Oh, so when you were in the Canaries, I noticed that due to an excess of rainfall, how green everywhere was at every even altitude. It's the same on Mount Teddy. Not so much, but what you do find is a very local climate on all of the islands here. And in fact, I was telling Andrew about the neighboring island of La Palma, where the Roque de las Muchachas Observatory is. That's where the largest optical telescope in the world is based, the Grand Tecan telescope. That island is known as the Green Island, but actually it's only green at one end. It's green on its north end, which is where the prevailing winds come and moisture comes in. So you get all this moss hanging off the trees. But really, the Canary Islands are generally known as the Spring Isles because they have a kind of all year round spring climate, even though we have had some pretty bad conditions up here at points. So Daryl, maintenance program proving great success. I see dome camera, and you have a squatter. Okay, well we'll check that one out. We did notice that. We noticed that enormous flyer as well, didn't we? On there the other day. Look, this monster was taking up half the sky. I know the shutter problems in 2.2 has been resolved and the images are great, but I have noticed on a couple of images an anomaly. We'll check that out later. We do have new flats and calibration frames to do on Canary 3. Somebody else asking there. Gremlins, yeah. Thank you very much still for being patient, having difficulties getting reliable. Yeah. And we're coming down to the end, going live. Yep, there we are. Paul, just started watch. Hi, Muazzaz. Question, did you say a while ago that you were planning to move the T1 into Dome 2? So in other words, switch the Canary 1 and Canary 2 telescopes so that T1 will not be disturbed so much from the winds. Maybe I imagine, no, you're not dreaming. That is what we said. I'm just going to turn around, and Andrew, if you can come around the other side as well, because we've been facing the sun and we shouldn't be doing that. The UV up here is so strong. It's even silly at this time of day to do that. No, we have debated that, as really since we've been here. I've been asking Andrew's opinion on it as well, now that he can see things up here. What we're going to do in the short term is what we said at the top of the show. We're going to be raising the shutters of Dome 1 to help protect the half-meter telescope a little bit more, shelter it more from the wind. That's going to be our first stage, and this kind of winter period. We're then going to see how that goes over the winter months, over the rest of the remainder of winter. And then during the summer, we will be considering still switching Canary 1 and Canary 2. So just switching the telescopes from one dome to another, because the 17-inch telescope, Canary 2, sits a lot lower in the dome. But anyway, Andrew, maybe you could just close the south shutter, because we'll show people how the telescope moves. And this is quite cool. So we haven't really shown members this before. Oh, yep, camera's up the top, so that was just about to get sucked in by the dome. So let's have a look at the dome moving. All the way? Keep going, keep going, keep going, keep going. Yeah, we'll have to go all the way. So we have to go all the way because what we've got to do first of all on this, in fact, maybe Andrew, if you could get lower down, because you get some light from that door, because we're going to home the telescope first of all. Let's just shift along. We got 4 minutes left, folks. Let's just see. I'm just checking something. Right, we're going to do this really quickly because we are running out of time and the show will finish at the top of the hour. So the first thing we've got to do is, because I've been working on the dome, is we're going to home the telescope. Now, this is the telescope moving into a known position. So it's just about to do it now. And I'm actually doing this from our server in the United States. So we're going to see it start moving in a sec. If you press the right button, that is. There it goes. So you can hear the mount moving. So you've got two axes on a telescope. You've got the main axis down here. Sorry, Andrew, you can't see the screen very well. You've got the main axis down here, which is the right ascension one. So this is the one that tracks the stars. But up at the top, which is just disappearing from view, up here, this is the declination axis. So this is, So those are the two axes of the telescope. And there we can see it's just moving into the home position. Now, the reason why we had to close the dome to do that is because the sun is over in that region of the sky as well. So there it is in its home position. Now, I can't, unfortunately, actually, I'm just trying to think if we can quickly show it going to its azimuth position. But we're going to do that manually. So, Andrew, if you can hop over to this side, if you can climb around the half-meter telescope. And, I'll try and get Andrew in the same shot as this telescope because it is so difficult. Look at that. I mean, Andrew could comfortably sit inside that. I mean, it probably wouldn't do job prospects that well to get your feet on the primary mirror, Andrew. But if you could just now, I'm going to pull it down. I'm going to pull the telescope down manually into a position where members can see this problem of it being at azimuth. So we're going to be looking down in this area because we've got a couple of minutes left. Folks, if we get cut off, don't worry. We'll show you some of this stuff again. So I'm just going to lock that. Keep away from there. And, right, so Andrew, you're going to have to show the camera when it's getting all the way down here. So you'll have to get down on the floor as well, I think. Do excuse us, folks. So the telescope now, if Andrew points upward, you can see that the telescope is pointing virtually direct to the zenith. So that's the position right above the telescope. But have a look down here and you'll see when it gets to here, in other words, when it's past the meridian, so when it's crossed in this particular situation from east to west, you can get the back of the telescope and the camera very, very close to the mount. But anyway, listen, that is it. We have run out of time. We're going to go off air exactly on the top. top of the hour. So please join me in welcoming Slooh's newest recruit to Slooh, Andrew Dumbleton. You'll see him in the Slooh discussion boards. Thank you very much, everybody. We'll see you again very soon. Bye, everyone.